Welcome to Maths with EJD. In this video, I solve another structured problem in two parts. The first one is about this data. The following are the total 1969 and 1971 attendance figures for the 12 baseball teams in the then National League. Calculate the rank correlation coefficient. Rank correlation coefficient. That's Spearman's correlation coefficient. So we have the teams, 12 of them, I think, and their attendance or attendances in 1969, 1979, those long values. Thankfully, if it was going to be Pearson correlation coefficient, that would be a lot of calculation, but thankfully it's about ranking, so it's cool. Then the second part, we are given the scores obtained in a statistics test before and after teaching as follows. Of course, before is pre-test and after teaching is post-test. And we have the values the students scored before the test and the scores after the values before they were taught and the scores after they were taught. So the question is there a significant difference between the pre-test and post-test scores as a result of the teaching method adopted? So in essence, we are trying to see if the teaching method has had any serious impact on the performance of the student. So let's go on this journey. So the first part is about the rank correlation coefficient, which is otherwise known as the Spearman's correlation coefficient. Okay, of course, in the playlist, I already explained how to go about this. It has to do with ranking the values of the data set. So let's go with for the first one, uh, A now, to find the rank or Spearman's Spearman's correlation, correlation, correlation coefficient of the 1969 and 1971 attendance of the 12 baseball teams baseball teams recall that the Spearman's rank correlation can be computed as RS equals 1 minus 6 summation of the DI squared over n into n squared minus 1. So this is the formula for the rank correlation coefficient. So, my advice is once you write down the formula, you know what you have to do. So first thing, write down the formula, and then from there you can know what else you have to do. So here, uh, okay, like I always would do, right? The DI is actually the differences. So the DIs will be the difference between ranks of attendance for each team. Okay. And then N is the number of observations. N is number of observations. That's simply 12. Number of observations. Since there are 12 teams, then you have the N is 12 simply. So the next thing we have to do is write down the figures and try to do the ranking. Let's see how this goes. Okay. Okay, still back to black. Okay, we have the team. We have the year 1969. We have the year 1971. And then, of course, okay, another thing we need is we need the ranks, right? We need the rank for 1969 And then we need a rank for 1971. Then apart from that, we now need the differences between the ranks. Those are the DIs. And then from the formula, you can see that we need the square of the DIs. So we now need the DI squares. Okay. And so with once you get this table right, you're good to go. Basically. Okay, so let's start. Let's fill in the values. It's actually a lot, but let's do it. So the first thing is, well, as a Nigerian person that I am, I would call this Atlanta, but Americans, I know they call it something like Alana or something like that. So one for 1969. So this is 1,458,000, 1,458,000, 320. That's the attendance for Atlanta in 1969. And in 1971, the attendance was 1,006,420. I'm putting the commas so that it will be easy to see how big the values are. Then the next one is Chicago. Another one mistake non-Americans, I mean people that don't know make is they call it Chicago. But I mean it's a statistics class, so I don't care like that. All right. So for Chicago, we have 1,000,000 1969, the attendance was 1,674,993. And then for 1971, the attendance was 1,653,007. Okay. Then I go again. The next one is, well, the Nigerian guy in me will say it is Cincinnati, but I know it's something like Cincinnati or something. So the attendance in 1969 was 987,991. And in 1971, it grew to 1,501,000, 122. 1,501,122. And then we go for the next one, that is Houston. I think I would agree on this a lot. Houston. And then, so for Houston, we have in 1969 it was 1,442,995. And in 1971, Houston's attendance was 1,261,589. Then we go for the next one, which is Los Angeles. Los Angeles. So 1969 attendance was 1,784,527. And then the 1971 attendance was 2,064,594. And then we have Montreal. Montreal. Montreal is 1,212,608, while in 1971 it was 1,290,963. So Montreal, 1969, 1,212,608. In 1971, 1,290,000, 963. Then we go to New York. New York. So New York, we have for 1969, 2,175,373. 2,175,000 to 373, actually 373. And then for 1971, it was 2,266,680. Okay. And then we have the next one, which is Philadelphia. Philadelphia. Brotherly love. Philadelphia. So for Philadelphia, 1969 was 519,414, and 1971 was 1,511,233 for Philadelphia. 519,414, then 1,511,233. Then we go to Pittsburgh. Pittsburgh, um, Pittsburgh, Pennsylvania. That's Pittsburgh. Okay. So for Pittsburgh, we have 769,368. And then 1971 was 1,501,132. 132. Then we have St. Louis. St. Louis. So that would be 1,682,783. And then 1971, 1,604,671. And then we have San Diego. San Diego. San Diego in 1969 was 512,970. And then 5,549,085. The slight increase. 512 from 512,970 to 549,085. And lastly, we have San Francisco. San Francisco. So this is 873,603. And then in 1971, it was 1,122,599. Okay. So that's what that has been like. So we need to do the ranking now. It's better to see everything together so that we can rank correctly. So let me rank with the red markers. So for 1969, the the highest value for 1969, of course, I want to hazard that it to be New York already. I mean, for obvious reasons, but let's see. Let's be very sure of that. Look at the valleys. New York is 2 million, so clearly the number one. So New York is number one for 1969. New York is number one. Okay. Then number two for 1969 would be number two. So after 2 million, right? We have number two, 1,784,000. That is Los Angeles. That's number two. And number three is 1,682,000. That is St. Louis, number three. Then number four is Chicago, 1,674. 1,6784. So 1,674, Chicago, number four. Then we have number five is Atlanta, or if you like, Atlanta. So number five is that. Then number five is that. Then number six is Houston. After 1,458,000, number six should be Houston. Number seven should be Montreal. Number seven is Montreal. Number eight is Cincinnati. Yeah, I believe so. Number eight is Cincinnati. Then number nine is San Francisco. Number nine is 873. Number nine, number nine is San Francisco. Number 10 is Pittsburgh. Pittsburgh, number 10. Number 11 is San Diego. Number 11, San Diego. And the list is Philadelphia, number 12. I think something is wrong here. Um, something is wrong. Philadelphia is 519,000, right? Philadelphia is 519,000. So Philadelphia, okay, let's check. Philadelphia is 519,000, and then San Diego is 512. So Philadelphia should be 11. Philadelphia should be 11. while San Diego is 12. So Philadelphia is 11, San Diego is 12. So let's check again. 2,175 yes. The second one is 1,784 yes. Three is 1,682,4. 1,674 correct. 1,458 good. Six 1,442 nice. Seven 1,212,8. 987. Nine is 873 correct. 10 is 769. 11 is 519. 12 is 512. Okay, so that's how that would be. So let's move to 1971. Let's rank the attendance for 1971. Again, New York seems to be the number one again. So 2,266. There's no other 2 million, so that's number one. Then number two for 1971, I think it's still Los Angeles with 2,064. Oh, okay, yeah. There's another 2 million. That's also number two. Then number three seems to be Chicago 1653. Chicago 1653. That's number three. Chicago 1653. Then number four is St. Louis. St. Louis 1604. 1604. That's number four, St. Louis. Number five should be Philadelphia in this case. Number five, 1,511. Yeah. Philadelphia is number five. Number six. Number six should be Pittsburgh. Philadelphia 1511. Pittsburgh is 1501. That's number six. Pittsburgh. Number seven should be Cincinnati. Number six. Philadelphia is 1511. Then Cincinnati is 1501. That's number seven. Philadelphia. Uh, Cincinnati. Number seven. Then number eight should be Houston, 1261. Houston, 1261. Where is it? That's number eight, right? Houston is number eight. Number nine should be Montreal, I believe. That's 1290. 1290. That's number nine. Number 10. Number 10 after Montreal is Atlanta. Number 10, 1006. That should be number 10. Number 10, yeah. Number 11, of course, easy choice now. San Francisco is now number 11. Okay. San Francisco is now number 11, while San Diego is number 12. Okay. So let's check that again. 1969, New York number one, Los Angeles number two. Number three is St. Louis. Number three St. Louis. Number four Chicago. Number five Atlanta. Number six Houston. Number seven Montreal. Number eight Cincinnati. Number nine, San Francisco, yeah. Number 10, Pittsburgh. Number 11, Philadelphia. Number 11 is number 11. Yeah, number 11 is Philadelphia because it's 519, while the last one is San Diego, number 12. Okay, so for 1971 now, New York is number one. Two. Okay, let's see that. New York 2266. That's New York number one. Number two is 2064. Number three, 1653. Number four, 1604. Number five, 1511. Number six, 1501. Number seven. Oh, 150132. Okay. Number seven, 1501122. Correct. Number eight, 1261. Number nine, one, two. Aha, aha, something is wrong here. Mm, 1261 is not okay. Yeah, 1261 is okay. Number eight is 1261. No, that's not true. Number eight is 1261, and number nine is 1290. No, 1290 is bigger, right? 1290 is bigger. So we may have to switch that. 1290 is bigger, so it should be number eight, and 1261 is number nine because 290 is bigger than 261, right? So eight is Montreal, eight is Montreal, nine is Houston, because Montreal is 1290, while Houston is 1261. Okay, nine now. Nine is okay. Nine is 1261. 10, 1006. Good. 11 is another issue there. Uh okay, we have to switch that too because uh one 1122 is bigger than 100. So this should be 10, while Atlanta is 11. Yeah. 1122 is bigger than 1006. Okay. Then 12 is obviously 549085, which is San Diego. Okay, so that's how that would be. I think that's the hardest part. In case I make a mistake, try to make sure you don't make the same. But I think I've tried as much as possible to ensure there's no error. But I mean, under exam situation, you have to be really very careful because it's easy. In fact, if you can avoid this question, please do. If you can avoid it, please do. But if you don't have a choice, you have to be extra careful. So let's go now for the so I mean the hardest part has been done already. So the difference is now 5 minus 11 is just minus 6. Then 4 minus 3 is 1. 8 minus 7 is 1. 6 minus 9 is minus 3. 2 minus 2 is 0. 7 minus 8 is minus 1. 1 minus 1 is 0. 11 minus 5 is 6. 10 minus 6 is 4. 3 minus 4 is minus 1. 12 minus 12 is 0. 9 minus 10 is minus 1. So that's pretty easy. So that lastly, again, let's check. I mean, you have to keep cross-checking. 5 minus 11 is minus 6. 4 minus 3 is 1. 8 minus 7 is 1. 6 minus 9 is minus 3. 2 minus 2 is 0. 7 minus 8 is minus 1. 1 minus 1 is 0. 11 minus 5 is 6. 10 minus 6 is 4. 3 minus 4 is minus 1. 12 minus 12 is 0. 9 minus 10 is minus 1. So the squares of this will just simply be minus 6 squared is 36. 1 squared is 1. 1 squared is 1. Minus 3 squared is 9. 0 squared is 0. 1, minus 1 squared is 1. 0 squared is 0. 6 squared is 36. 4 squared is 16. Minus 1 squared is 1. 0, 1 like that. So we need summation of di all squared. So I think that's easy to do. 36 plus 1, that's 37, 38, 47, 48, right? Yeah, 48. Okay. 48 plus 6 plus 48 plus 36. 48, 48 plus 36 plus 16 plus 2. That is 102. 102. So let's be sure again. 1 plus 1 is 2. Okay, first of all, 36 plus 36 is 72. We can take that out of the way. So we know we have 72 for the big numbers. So the small numbers, 1 plus 1, 2, plus 9, 11, plus 1, 12, plus 2, 14 in short. So 14, no. 36 plus 36 settled. Okay, let's say 36 plus 36 settled, right? So 1 plus 1, 2, 11 plus 1, 12, plus 16, that is 28, plus 2, that's 30. So 102 is correct. All right, so we have, so now that we have that, we can move on. We can move on. So don't forget the formula again. How many data points? That's 1, 2, 3, 4, 5. We've been told already 6, 7, 8, 9, 10, 11, 12. It was told us in the question. So we just know that n is 12. So all we need to do now is compute RS. So we can say, therefore, RS, which is 1 minus 6 summation di squared divided by n into n squared minus 1. Okay, that's what the formula is. And then RS now is equal to 1 minus 6 times summation of di squared is 102 divided by n into n squared minus 1. That's 12 into 12 squared minus 1. So that RS is equal to 1 minus 6 times 102 should be 612, I believe, all over 12 into 144 minus 1. So that is RS equals 1 minus, okay, let's do this neatly. So that is 12 into 144 minus 1. That is 612, right? 612 divided by 12 into 143. So that is RS equals 1 minus 612 divided by 12 times 143 now. 12 times 143. So that is 1716. 1716. So that RS is equal to 1 minus 612 divided by 1716. That is 0.3566. So that RS is 1 minus 0.3566. 1 minus 0.3566, and that is 0.6434. Okay, so that means that the rank correlation coefficient is 0.6434. I think that's basically what we need. Yeah, that's what we need. So, and what does this mean? This is a bit above, normally for rank, right? You have, so let's say generally, if you have 0 in the middle, no, this means no correlation, right? So if you go like 0.5, this is weak, should we even say weak correlation? Uh, we can say very weak correlation, yeah? We can say very weak. Okay, let me just leave that and come back later. You have 0.5, then from 0.5 to uh let's say to 1.0. I mean, we have classifications for all of these things, but let me just say, let's say this is weak. From 0 to 0.5 is weak correlation. We can divide it further, right? But let's just say weak and strong in this time. So this is strong correlation. So that is weak positive correlation and strong positive correlation. Yeah. Of course, you can go the other way too. You know, we can go the other way where we have minus 0.5, and then we have again minus 1.0. So this will be weak negative correlation, weak negative correlation. And so here will be strong negative correlation. Negative correlation means that as one is increasing, the other is reducing. But positive correlation means the two are increasing together. Okay, so since we have 0.64, so it's already falling into not so weak, right? Okay, so um, with Spearman, with rank correlation, of 0.6, 0.6434, the attendance values, for 1969 and 1971 are are moderately moderately strong, are moderately okay. Let's just say are moderately positively correlated. I think that may be a nice way to put it. Moderately positively correlated. Okay. And that's what we are expected to find. I mean, we just need, these are all we need, right? But this extra thing is just to, add some spice to it. Okay, so we have the next thing now. We have some scores. So given the scores obtained in statistics tests before and after test, so we just want to know, is there any significance difference? Now, when I was doing the playlist on both parametric and non-parametric tests, so if you look at this now, the same set of people are tested under different conditions. In that case, yeah, so you already know it has to be some paired test because it's the same set of people. So if you get some values from the same set of populace, if you get the same sample and you get values from them under different conditions or at different time points, then you know that's some paired sample. And so since you know it's paired sample, will it be paired Z test or paired T test? Now, paired Z test works for when you have large population, like N is 30. But here, N is less than 30. N is just 1, 2, 3, 4, 5, 6, 7, 8. So 8 data points. That means you're going to go for a paired T test, basically. So in that case, that's how it comes. So we go for the B part now. Okay. Given given the pre-test, given the pre-test and post-test scores. Is this scores used there? I like to answer questions exactly the way they asked. Okay, scores, right? Um, given the pre-test and post-test scores of students in a statistics test, and since the number since the number of students since the number of students since the number of students which is n, is just equal to 8. 1, 2, 3, 4, 5, 6, 7, 8 is equal to 8. We can use we can use the paired t-test. The paired t-test defined as defined as um so the definition of the t-test, yeah, it's so the test statistic is defined as T equals D bar all over uh all over SD divided by square root of N. Okay, divided by square root of N. And what are these parts now? So D is the mean of the differences. Mean of the differences, and SD is standard deviation of differences. Standard deviation of differences, and N is the number of pairs or number of observations, number of pairs. So it's better to call it pairs since we are doing this paired sample t-test. So, this is what this is about. So that's the test statistic because, we have values from the same students under different conditions. Now, so what we have to do now is to get those values out. So we need the standard deviation, and we also need the mean of the deviation. So first, let's get the deviations. Okay, so let's see pre-test and post-test. So that's 14, 10, 14, and so on and so forth. Okay. Mm. So, we just need the absolute value, right? We don't care about the sign. So this is what we do. Let's say this is pre-test, right? Pre-test. The values for pre-test are the values of pre-test are 10, 8, 9, 11, 12, 10, 8, 8. And the values for post-test would be these are 14, 14, 13, 12, 15, 15 again, 10, 12, 13. Okay, like this. I've actually wasted space by writing them in full, but it's okay. So we need the absolute value of the deviation. That's important. Then after that, of course, we need the summation of that, definitely. Then we also need, so after getting that, right? Um, then we now need the standard deviation. Mm, okay, I mean the mean value is going to give us that already. So I guess we can just try to think. Okay, yeah. So let's do it this way. So we need D. So D sha is absolute value of pre minus post. Let's do it that way. Okay, just want to see if I can do everything in this table at once. And then we can now have so D minus D bar. We need D bar here. So we can easily find D bar. We can easily find D bar by summing up this and dividing by the number of points we have. So we can have D, we can have, let's call it DI minus D bar. Okay. And that's for this. So we can also get the sum of this, and that would have been fine for. Okay. I mean, what I'm actually doing is this. So we need D bar. D bar is simply summation of D divided by N. Okay. That's number of items. So basically that's what I'm doing. Okay, so let's go. We have all this now. So 10 minus 14 is minus 4. That's just for absolute value. This is 5. This is 3. This is 4. This is 3. This is 0. And this is 4 again, and this is 5. Are we good? 14 minus 10 is 4. 13 minus 8 is 5. 12 minus 9 is 3. 15 minus 11 is 4. 15 minus 12 is 3. 10 minus 10 is 0. 12 minus 8 is 4. 30 minus 8 is 5. Okay. So now we need the summation of all this. The summation of all this is 4 plus 5, 9, 12. Oops. Okay. 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 So we need the summation of all this. 4 plus 5 is 9. 9 plus 4 is 12. 12 plus 4 is 16. 16 plus 3 is 19. 19 plus 9 is 28. Let's do that again. 9 plus 7 is 16. 9 plus 7 is 16. Plus 3, 19. Plus 9 is 28. So, and of course, n is the number of points we have. That's 8, right? So that means this is equal to 28 over 8, which is 7 over 2. And that is simply 3.5. This is 3.5. Okay. Now, we also need the standard deviation. So we need the standard deviation, SD. SD is simply summation of DI minus D bar divided by summation of, divided by N in short, divided by N. Is it divided by N or N minus 1? I think it's divided by N. But if it's N minus 1, please adjust. But right now, I think it's N minus 1. So we have di minus d bar. D bar is 3.5. This is d bar. So 4 minus, in fact, can we just square? Can we just square? 4 minus 3.5 is 0.5. 5 minus 3.5 is 1.5, right? That's 1.5. 3 minus 3.5 is minus 0.5. Yeah. 4 minus 3.5 again is 0.5. 3 minus 3.5 is minus 0.5. 0 minus 3.5 is minus 3.5. 4 minus 3.5 is 0.5. 5 minus 3.5 is 1.5. And then we now have di minus d bar all squared because we need the sum of all this. Okay. We need the sum of this. So I'm already flouting my rules. Don't trust your brain under pressure. Okay, 5 times 5 is 25. We already know that. 0.5 times 0.5, that's this will be 0.25. 0.25. Then 1.5, 15 times 15 is 225, I want to believe. So 2 decimal places should be 2.25. Let me be very sure of that. 1.5 times 1.5. That is 2.25, correct? 2.25. Then, of course, this is just 0.25, 0.25, 0.25. Happily so. Then 3.5 squared, 3.5 times 3.5. That is 12.25, 12.25. Again, this is 0.25 and this is 2.25. So let's add all of that together. 0.25 0.25 in how many places? Okay, let's just go. 0.25 plus 2.25 plus 0.25 plus 0.25 plus 0.25. That's three 0.25s plus 12.25 plus 0.25. 12.25 plus 0.25 plus 2.25. I go again. 0.25, 2.25, 0.25, 0.25, 0.25, 12.25, 0.25, 2.25. So all that is 18. So summation of di minus d bar squared is 18, interestingly. So we have 18 for standard deviation. Yeah, this is 18 divided by 8, which is 2 goes 9, 2 goes 4, and then that is 4 in 9. Okay, 9 over 4 in short. 9 divided by 4 is just equal to 2.25. 2.25. Okay, so we have all we need like that. We have all we need. We have this and we have this. So we have everything we need. So we can get the t statistic already. So we can say therefore t, which is d bar over sd divided by square root of n. Okay. So is equal to okay, this is actually squared, right? But I mean we did the right thing already. So this is d bar, which is 3.5. Is 3.5 divided by SD. SD is 2.25. 2.25 divided by square root of 8. Okay. So this is T equals 3.5 all over 2.25 divided by square root of 8 should be 2 point something. So that's square root of 8. Square root of 8. That is 2.28. 28. I mean 2.8284. 8284. so that this t now is 3.5 divided by 2.25 divided by 2.8284. 2.5 divided by 2.8284. So now approximation sets in. So we have, this is 0.97955. So that t is approximately 3.5 divided by 0.7955. 0.7955. Okay. And that is approximately 4.3997. So that's the test statistic. So you can say something like, therefore, t test is approximately 4.40, that's like 4.40. So, of course, you should start with the hypothesis, right? The H naught is that, there's no significant difference. No, okay, let me just summarize. No significant difference, pre-test and post-test, pre-test and post-test. And alternative hypothesis H1 will be there is significant difference. There is significant difference. Okay. But now we have calculated the test statistic. So the next thing we need to do is we need to find the critical value. Okay. We need to find the critical value. That's what we have to do next. Okay. Okay, so having done that, right, we can now say, okay, the critical value for for n equals 8 with degrees of freedom equals 7, and a significance level of alpha equals 0.05. We're not given this, so we'll just take this because it's popular. It's most common. The critical value for n equals 8 with degrees of freedom equals 7, and the significance level of alpha is 0.05. From the t distribution table is approximately 2.365. 2.365. So master your table. So 2.365. So in short, what we now have is that t test is approximately 4.40, 4.40, whereas T critical, that's the critical value we just found, is approximately 2.37, 2.37. Obviously, we have the T test is greater than the T critical, so that means we reject the null hypothesis. So just say since T test is much larger, than the T critical, and the T critical, we reject the null hypothesis. We reject the null hypothesis. The null hypothesis says that there's no significant difference between the performance before the teaching and after the teaching. But now this test is telling us that there's actually a significant difference because we reject that. So we can now say, therefore, there is a significant difference. There's a significant difference between the pre-test and post-test scores, indicating that the teaching method, that the teaching method had a significant effect. So if you are trying out a teaching method to see its impact, then this kind of test now has shown that, okay, you should continue with this teaching method and discard the old one. So with this, we come to the end of this video, I believe, because these are the two things we are required to do, and they have all been done now. So yeah, adopting the new teaching method is effective because it helps the performance of the students. So that method should be continued with. So if you have not subscribed to this channel, please do that and hit the notification bell so you can always get informed whenever a new video is released. And don't forget to like, also comment. Comment, let me know if you want me to teach a topic or solve a problem. And then don't forget to share with others so that more people can have access to this great learning. Till I come your way again, have a great time. Bye.